Great. So my name is Ahmar Kazi. I go by Kazi, so my friends call me Kazi, I guess. I am an innovation architect. I report into the office of the CTO in the Microsoft consulting organization. I've been with Microsoft for 15 years. I'm a software engineer, kind of background by trade. I'm a graduate in computer engineering. I did my master's from California State University, Fullerton, in software engineering. And then at Microsoft, I've had 15 years. I've been in like 7, 8 different roles. Last few years, I've had some focus on AI, but I've also looked at purely from an innovation standpoint, the intersection of AI and mixed reality and IoT and some of the upcoming trends and their application in industrial solutions. For today, I thought it'd be good to talk about AI operationalization as a concept. So I'm glad Marcin softened things up for me because a lot of the initial conversations were very technical. And the context that I wanted to present is because I work for Microsoft Consulting Organization, we often get tasked to build AI practice for our clients, right? So some of our clients are looking to build practices that will then develop many models. At running a practice, an AI practice, where you have hundreds and thousands of models being developed, and the life cycle of that model involves very constant retraining and deployment activities, then we want to look at the AI operationalization more holistically and look at all the concepts that are involved. And some of it requires tooling, some of it requires process optimization to ensure that you can run AI at scale and run it with consistency and a level of efficiency. So I'll walk through some of those concepts, and then hopefully we can have a conversation if there's time permitting. So since we already talked about the whole team data science process, and I'm glad it's taking good traction in the industry. Typically you have this process involves typical business understanding, data collection, transformation. You build the model and then you deploy it and monitor it, and then eventually you want to make sure there's value being realized out of that model. As you run this process in your organization, and what are the different ways we can what are the different you could say concerns that we need to tackle in order to do this at scale. So we'll start with some of the concepts involved in data collection. So business understanding is business understanding, right? You need to know the domain. You need to have expertise from the domain, because a lot of the data you're dealing with is, you need to understand what's behind it, what's the meaning of the data you're working with. But when it comes to really dealing with the collection and ingestion process, there's a lot of data discovery and data cataloging that is involved, right? So if you have an enterprise that has a vast sources of data sets, you may want to look at some discovery and data cataloging capability to make it easier for your data scientists as they go out, build new models in order to discover that data, but not just discovery of that data, but understanding what are the constraints related to that data. Can I use that data to train models? I think there's a lot of privacy and compliance requirements where it's possible that your organization may have certain data sets, but to be able to train AI models on those data sets, are perhaps not allowed. So understanding what that full catalog is and what are the constraints, and really documenting it and providing tooling for a data scientist to discover that would be I would say an important trait in the practice. If you have, obviously there's a lot of ingestion process that runs when you're dealing with building machine learning models. So you definitely want to automate that ingestion process as much as possible. When you're connecting to different data sources, you're obviously dealing with a lot of authenticated sources, which means there's a credential management a challenge, and you want to handle that securely, right? You don't want your data science practice to become, the least secure endpoint in the enterprise. You want to make sure that any connections that are being established across your enterprise for the data discovery and data ingestion, those credentials are properly secured and managed using a disciplined approach. In some types of models, you may be dealing with data labeling, right? So if you're specifically building machine learning, computer vision type models, the labeling process could be quite involved and taxing. So if there is a way for you to make that labeled data available for other members in your data science team or other data science team in the organization to leverage, that would also be a good way to maximize your efficiency. If you're dealing with machine learning problems like the one Thomas talked about with the multi-banded, those are typically reinforcement learning related. And when you're learning by experience, you typically involve some form of simulation. So having a good handle on what that simulation standard is, if your organization is looking at RL type use cases, and really have some level of expertise built up and IP built up on what those simulation environments are and how other data scientists can use them to train their own models. So these are some of the traits that cover the data collection, generation, and ingestion process. If there are questions you want to just pop in, I'm happy to answer as we go along, or we can wait till the end. Let's talk about the data exploration, transformation, and schematization phase of the TDSP process. So again, sharing and collaboration is, you want to offer tooling that allows different data scientists to be able to share their transforms, use other data scientist transforms, and then build pipelines against it. Any transformation that you're doing just as a standard practice, you want to have it as part of a pipeline so that when you do inference, you're running the same transforms when you're bringing in your real world data, the transforms that were applied for training. So standard practice in most data science activities. And then just versioning, your pipelines and all the data transforms. And then there's, in some cases, when you're dealing with compute environments that are competing, like different people are competing for those compute environments because they need to do, run their complex transforms or run training requirements, then you may want to have some sort of batch scheduling process to ensure that, different teams and data scientists can appropriately schedule their events and there's no conflict there. I'll move on to model building and tuning activities. So kind of looping in the entire kind of, once you've done the transformation, now you're building out the models. One thing that could be really helpful is if your organization had like a model catalog where the data scientists can look back and see what models have we developed. Is there IP that can be repurposed? Are there learnings that we should be repurposing? In this process, if you're doing a lot of featureization work, I've had customers request an ability to have like a catalog of features. So if one data scientist created a feature out of their enterprise data sets, they want the other data scientists to be able to leverage those features. And especially when it comes to AutoML type use cases where you can feed as many features as you want and see what the different outcomes would be. If someone has done some very unique featureization work and the system allows you to repurpose that work, that could be really, really beneficial. But just in general, any model build activity, you want to have versioning that captures all the different parameters, what algorithms were used. You may want to, in some cases, there's a requirement for traceability. So you have to really attach any data sets that were part of that training activity. Because in the end, if it's a sensitive use case, there may be a requirement to go back to the original data set and do some investigative work. If you're doing a lot of auto ML, then auto ML configs could also be part of that versioning activity. So when it comes to the model build, versioning that build and making sure that you can go back to different versions and there's a history and log behind it would be a very essential trait in a AI operationalization environment at scale. In some organizations, before you can do anything with your trained model, it has to go through expert reviews. So having a collaborative workspace that allows some sort of a workflow to trigger that allows senior data scientists or a committee to review the work that was done and the accuracy that resulted in the training. So that would be another important trait in the practice. When it comes to deployment, so again, some of the things that Marcin was also talking about is that the role of the data science engineer is evolving, because it's not just about building good models, it's about making sure they're deployed in a way that they are secure, they can provide the right SLA, the performance is relative to the use case that the model is implementing. So all of those traits come in really handy when it comes to deployment and monitoring type activities. You want to make sure that you have very good clarity on what the resiliency is that is expected. So if it is a model that could deny a loan application, for example, that could have a direct impact on somebody's life. So just making sure that you have the right resiliency in place to provide that type of SLA. The software engineering, like the continuous integration and continuous deployment processes and tooling, is very relevant now with data science, right? You want to have that CI/CD pipeline build out that fully automates all the way from even provisioning your training infrastructure to doing the data ingestion, doing the transformation, doing the training, as well as publishing that environment onto the published endpoint. All of that can now be automated. There's tons of tooling available. I can certainly speak to the Microsoft tooling, but there's in the industry there are quite a few options out there. Performance. So for inference, what is the latency expected when you get the results for that model? Are you monitoring for drift, right? A lot of it, it could be data drift, it could be model drift. So different tooling and techniques are available in order to monitor the drift. Pandemic is a great scenario where just everything changed. So any models that were trained in terms of our previous way of life, and that data set was used, there would definitely be a drift that would have come up just by way of our new way of life. And then just understanding what are the KPIs behind the model. So the model accuracy is one thing, but your KPIs may be more business centered, right? So in this could be in terms of how many clicks were redirected to the right endpoint, right? It could be really use case specific, and understanding what those KPIs are and being able to visualize and report on it would be again a very important trait to have in an AI practice that can scale. And then getting notification and triggers when things are not going as planned, and when you're seeing drifts and other type of issues that require a notification. So having that service available would be key. So we talked about these traits from the lens of the team data science process, but there are other very important traits underneath that I mentioned. Here is governance. So in a lot of organizations that are looking at AI as a practice, they would have like an AI manifesto, something that really identifies what their company's view of AI is, how it can and cannot be used, what is the governance policy around it. Organizations must have some ethics process to ensure that if there's a sensitive use case being implemented, there's proper thought being given to what that use case is and whether it's ethically viable, and then have like the tooling available to identify bias in data and making sure that there is proper traceability and accountability when it comes to building out those models. Security, if you have blueprints that already kind of take the security aspects into account, that's great. Adoption, so this is the second layer that I talk about, is having an adoption and change management practice. So a lot of times, like in some use cases, you have AI that is augmenting the work that users are doing. And in those cases, you may want to watch for how much of that augmentation is actually taking effect. Are the users actually using the results from the AI engine? Are they simply discarding it? And just understanding that behavior, understanding that metric, and then having a proper process to ensure that there is an adoption discipline being applied to systems that are being rolled out that are AI driven would be another important trait in a practice. And then the service management is just having clarity of roles and responsibilities, having all these processes in place would also be critical. So it's one slide, but it kind of captures a lot of different disciplines and different traits that an enterprise or an organization will need to have in order to scale their AI initiative and be able to deploy thousands and hundreds of models at a very fast pace, and then obviously look into all the different efficiencies and productivity benefits that it lands for the data scientists, for the engineers. So I know I did a lot of talking. If there are any questions, comments, feel free to please raise your hand.
Awesome. Thanks for
Adam
that.
has his hand.
No, that's all right, mate. I was raising my hand for the audience. So, look, thanks so much. Yeah, super insightful. As I was saying before, yeah, really pleased to have someone from Microsoft present. We've only been doing our meetup since April, and to tick off one of the biggest tech companies in the world at our humble little community is really appreciate that. So we did have a question for you there, and the question is from Thomas, who was one of our presenters from earlier at Unbounce. He said, "I'm curious for all of these pieces, which team or teams are responsible for what? How do you establish contracts and work cross teams to coordinate?"
Yeah, it's a great question, Thomas. It really comes down to how the organization is kind of the enterprise is organized. We are seeing a shift to this DevOps principle where a lot of the engineers who were responsible for developing the product are now becoming responsible for even maintaining it and operating it. So if you take that shift into account, you could say that the role of the data scientist is you will always have some of your core data scientists that will continue to focus on the problem space, finding the most optimal algorithms and the right features to train the model on. But that ML engineer role that Marcin talked about is now becoming more and more relevant. And you want that ML engineer to be part of your core practice, right? Ideally, it's not somebody that is completely separated from the core organization, because they need to keep in mind all the ML specific intricacies, but they also need to have skills in like DevOps and CI/CD workflows and being able to run ARM templates and provision infrastructure for training, things like that. So that speaks to what the core skills you need on the team. But absolutely, there are contracts anytime you go beyond that core team. Like for instance, if you're pulling a lot of data from different sources within your organization, there's a contract right there, right? Because you're pulling data sets that belong to a different part of the organization, and you need the owner of that data set to also offer their constraints. So that means that they need to be a participant in this, and they need to make sure that when they publish that data set, all the metadata associated with what that data set, right to use, and what attributes are okay to train models on, and which attributes are considered sensitive. all of that contract has to be in place for the data publisher. Same thing goes with the deployment side of it. If you're deploying it to a production, cloud environment, and then a different team is responsible for maintaining the cloud, the production infrastructure, then they're likely the ones that are monitoring it. So just having that contract in place with them on what metrics to monitor on and what performance specifics to look for would be another contract. Hopefully I answered the question in the spirit you were expecting it.
Yeah, excellent. Thanks for that, Kazi. So we have another question from Philip. Philip has asked, I'm curious if you use Linux or Windows for the AI systems you deploy or build.
So in our case, we are agnostic. A good chunk of Azure infrastructure, runs Linux. So Linux is a first-party kind of operating system as far as Microsoft goes. So my personal experience is, if I am running compute, I could run it on the Azure Machine Learning Compute, which you have a choice. You can spin up different types of VMs. You can spin up Windows or Linux VMs. For the most part, it's Linux. And then if you could also use Batch AI, which under the hood is kind of proprietary tech, but it gives you an interface to run very high compute on. So there are different choices that are available, and really, it really comes down to compute. Compute is compute. It doesn't really have a lot of significance on the operating system.
And then Phillips also asked, do you use WSL2?
I am not familiar with that.
Me neither.
Is it the security layer protection? I think that's what comes to mind.
I'm not too sure. Maybe you can clarify that there, Philip, in your question there. Here we go. Windows subsystem for Linux.
Yeah, I don't know if I have the depth to comment on what the options for the compute and the OS environment would be. Like you have an ability to run your training on different platform choices. You can spin up a DSVM. You could have a Databricks cluster, a Spark cluster, where you can run your training models on. You can spin up Batch AI, Azure Batch AI, that also allows you to do training. You have specialized VMs that are GPU enabled. A lot of the kind of the high compute, like computer vision type workloads, that's what they choose to do, is they use the GPU enabled VMs. So you absolutely have a choice to go all native Linux and run your training models on Linux.
Great. And we have a question from Avernus. Do you recommend functional programming, i.e. F, for building AI models?
Most of my peers, they use Python for their kind of core programming. I know that there are frameworks like ML.NET that are potentially available on F. Like you could absolutely do it on C#. Like a lot of our developers use ML.NET libraries and run models on C#. But if you're looking for majority of them developed their data science, their machine learning routines on Python. I know that's a tech audience, so I was thinking maybe I'll show you guys a few examples. Like we talk about this CI/CD pipeline.
Sure, far away.
So Azure, are you able to see my screen?
Yes.
Okay, great. So Azure DevOps is, our kind of DevOps environment where you can build these pipelines. So if I go into the pipelines feature, and so I have this DevOps pipeline for AI, and I edit this, you can see a kind of a glimpse of what that CI/CD pipeline for AI would look like, right? So you would get the resources, provision the resources, deploy Python, install all your requirements, get an Azure Machine Learning workspace created, train on local. In this case, train on local really means that it's going to use a compute instance within DevOps to do the training. But you can absolutely target it to like a VM or a different endpoint. Part of the pipeline, you could have like an evaluation of the production model. So this is an inline script. It runs that evaluate model.py. All of that code is stored in the repos. So you also have your version control and all of those engineering kind of features here. You can register the model in like the Azure Machine Learning workspace, create a Docker image, deploy that image, publish it. So this is just a basic example of what that CI/CD pipeline would look like using kind of Azure DevOps environment. I have a few other examples, like if you use Azure Machine Learning, you have a way to link your, let's say if you're working on a data set, you can register that data set with the experiment. So you basically you create a workspace, you create an experiment, and then you can register that data source with the experiment. This is just for that traceability piece that we talked about. You can also, like if you're building, let's say, if you're building doing some charting, you can actually log that chart in the workspace. So this will all become a permanent record in your experiment, and that image will be available for retrieval. So there are built-in tooling available in Azure Machine Learning in combination with Azure DevOps that allow you to build not all, but a good chunk of the traits that I talked about in the AI operationalization. Like I mentioned, not everything is a tool, right? Sometimes you need a process and you need a workflow that is more human-centered. The tools are just there to kind of support and facilitate that workflow. So hopefully this, for the techies, it gives them a little bit of a flavor of the different ways they can configure those different properties.